Welcome to World of Books today. We journey into one of the most mysterious and mind-bending books in modern science, In Search of Schrödinger's Cat by John Gribbin. Imagine a cat locked in a box, its life depending on the fate of a single atom. If that atom decays, poison is released and the cat dies. If it doesn't, the cat survives. Yet until you open the box, quantum theory tells us the cat is both alive and dead. Both? At the same time? It sounds like nonsense, doesn't it? But this thought experiment captures one of the strangest truths about our universe. How did we ever get here? Into a world where reality itself seems to bend under observation. That's the story John Gribbin tells. A journey from certainty to mystery, from Newton's universe of strict rules to the strange twilight of quantum mechanics. And as we walk through it, I want you to keep asking yourself, how real is the world you think you know? From certainty to cracks in the old world. For centuries, scientists believed the universe was like a perfect machine. Newton's laws could predict the future as long as you knew the present. Cause and effect, neat and clean. A comforting thought, isn't it? That everything is knowable, calculable, precise. But cracks began to appear. Max Planck studied glowing hot objects and found something absurd. According to classical physics, they should emit infinite energy, clearly impossible. So he took a leap. What if energy doesn't flow smoothly, but in tiny packets? Quanta. At first it was just a mathematical trick, but then came Einstein, who showed that light itself sometimes acts as a particle, a photon. Suddenly reality wasn't one thing or the other. It could be both, depending on how you looked at it. Doesn't that feel unsettling? The ground beneath certainty was starting to shift. Waves, particles, and a growing mystery. Bohr introduced his atomic model with electrons circling like planets around a sun. It worked, but why? Nobody really knew. Then Louis de Broglie asked a daring question. What if particles, like electrons, also behave like waves? The experiments proved him right. Matter itself could ripple. And then came the famous double-slit experiment. Fire tiny particles one by one at two slits, and they make an interference pattern, as if each particle traveled through both slits simultaneously. But if you watch them closely, they behave like little bullets, choosing one slit or the other. Think about that for a moment. When we look, reality changes. Could it be that our act of observing is somehow woven into the fabric of the universe? The birth of a new science. By the 1920s, physicists were building the new science, quantum mechanics. Heisenberg came up with matrix mechanics, Schrödinger with his wave equation. Two completely different paths, yet they describe the same mysterious world. Heisenberg uncovered a hard truth, the uncertainty principle. You can never know both where a particle is and how fast it's moving at the same time. Not because our instruments are clumsy, but because nature itself refuses to be pinned down. And Bohr added another twist. Before you measure it, a particle isn't in one place or another. It exists in a superposition of possibilities. Only when you observe it does the cloud of probabilities collapse into a definite reality. Now pause with that. Does the universe wait for us to look before it decides what's real? This was the puzzle that led Schrödinger to his famous cat. The cat in the box. Schrödinger wanted to show just how absurd the Copenhagen view seemed. If quantum rules apply to atoms, shouldn't they apply to bigger things too? That's how he dreamed up his cat, tied to a quantum event, both alive and dead until you peek inside. It wasn't meant as a serious idea for pets, of course. It was a challenge. If this is what our theory says, do we really understand it at all? And here's where the real philosophical battle began. Einstein's resistance. Einstein never bought it. To him, the universe had to be orderly and deterministic. God does not play dice, he declared. Quantum mechanics worked, sure, but surely it was incomplete. He and Bohr clashed fiercely. For Bohr, uncertainty was the essence of reality. For Einstein, it was a sign we were missing something deeper. Einstein, Podolsky, and Rosen crafted their famous paradox. If quantum mechanics were right, two particles could remain connected even when light years apart. Measure one, and the other instantly responds. He dismissed it as spooky action at a distance, but experiments proved him wrong. Spooky action is real. Entanglement is part of the fabric of our universe. What does that say about the nature of reality? Maybe everything is more connected than we ever imagined. Quantum becomes practical. For all its strangeness, quantum theory wasn't just abstract speculation. It worked with stunning accuracy. Without it, we wouldn't have transistors, computers, lasers, or smartphones. Every time you flick on a light powered by an LED, you're seeing quantum mechanics in action. Isn't it curious? The theory that baffled the greatest minds has quietly become the backbone of modern life. New ways of seeing reality. But the question never goes away. What does it all mean? Hugh Everett offered one radical answer. Many worlds. According to him, when a quantum event occurs, reality doesn't choose one outcome. It splits. In one universe, the cat lives. In another, it dies. Both are real. We just happen to follow one path. Others offered hidden variable theories like Bohm's pilot wave, suggesting there is a deeper order guiding everything. More recent ideas explore decoherence, showing how the messy, everyday world emerges from quantum fuzziness. Yet none of these interpretations is universally accepted. And maybe that's the point. Maybe reality is simply too strange to fit into any single box. The deeper mystery. So where does that leave us? We have a theory that can predict the tiniest details with breathtaking accuracy. We can use it to build technology that transforms our world. And yet, when we ask what it really means, we're left with paradoxes, debates, and mysteries. Do we create reality just by observing it? Is the universe constantly splitting into infinite branches? Or are there hidden rules we haven't uncovered yet? Maybe Schrödinger's cat is more than just a thought experiment. Maybe it's a mirror showing us how limited our understanding truly is. Closing reflection from Newton's clockwork. Certainty through Planck's quanta, Einstein's photons, Bohr's atoms, Heisenberg's uncertainty in Schrödinger's wave equation. We've journeyed to the very edge of what humans can know. We've seen the debates, the paradoxes, and the triumphs. We've seen entanglement prove that reality is stranger than any story we could invent. And yet, the mystery remains. Perhaps the most honest thing we can say is this. The universe is not only stranger than we imagine, it may be stranger than we can imagine. So the search for Schrödinger's cat goes on. Not in dusty boxes, but in the minds of all who dare to ask, what is reality really? Thank you for listening to this audiobook summary on World of Books. If you enjoyed this journey, don't forget to follow, share, and subscribe.